All right, class, let's go with it here. This is a practice test for chapter 5. We have a test coming up. Is that Monday? Is that what we said? Okay, let's go with it here. I'll let you guys try it first. Anybody tried it though beforehand? 1, 2, 3. Okay. We got to go change one into the other. That's all we're looking at here. Let's see. I'm thinking maybe the right side really needs a lot of work, right? The left side, I'm thinking which one needs the most amount of work. I think I'm going to go start with here. So tangent is sine over cosine. 1 plus, cotangent. So if I do tangent here, that doesn't help me. So I'm going to go cosine squared over sine squared. That'll be interesting. So now, lots of work with hardly any numbers here. We're going to distribute this little guy right over here. This is going to give us sine squared theta over cosine squared theta. And as I distribute over here, notice what's going to happen there. That's funny. Everything is going to cancel. Agreed? Absolutely. Everything cancels here. So that's going to be just a 1. Pactil 1. Okay. I'm not sure if I'm getting any closer to where I want to be. Let's see. How about, since this is just one fraction only, I guess I might as well make this into one fraction only. So I'm going to get common denominators, multiply through here with a cosine theta, Oh, square, that's right. I need a square in here, don't I? Because the common denominator squared. And let's see what I have now. See, on top I have sine squared theta plus cosine squared theta over cosine squared theta. Am I any closer? Again, can you guys help me out?
Pythagorean.
Oh, yes.
So it's just 1 over cosine squared.
Yep, that's Pythagorean theorem, which is sine squared plus cosine squared equals 1. That's cool. Anything else?
No, then there's the other one. So that equals 1 minus cosine squared equals 1 minus sine squared.
Perfect. This one, same consequence here. So off to the side here. If this is equal to 1, therefore cosine squared theta is equal to 1 minus sine squared theta. Then we're going to use this one right here. It doesn't really matter which way you go. You can either go this one, since we're working on the left-hand side, you can put 1 minus sine squared theta, or you can just bring this one all the way down. Keep this as cosine if you like. You can bring this one all the way down and just say, hey, you know what, by the same law, that's it right there. And I have QED on my hands. Are we good? Cool. All right. Tell me if I'm going too fast. I'm just going to jump up to the next one here. This one I think we did yesterday. I'm sorry, on Monday, did we? Sine theta minus cosine theta is equal to 1.
We did it. We added it.
Oh, okay.
Like it was sine theta
Plus cosine theta. Okay, cool. So this one is prove that each of the following is not an identity. And so we talked about last time the fact that it's like a clock that is right twice a day, but most of the time it's wrong. And so there are values here that if you do it, actually it will work out just fine. So if you use theta is equal to pi over 2, if you use that one and you plugged it in, and you're just trying to disprove this, not prove this. And you do this and you get yourself, so the sine of pi over 2 is 1. 1 minus 0 is 1. Hey, it works out. But theorems have to work out for every single angle possible. We're good? That's what identities are. So if you just choose another one, pi over 4, sine of pi over 4 minus cosine of pi over 4 is equal to 1. Does it really? We'll see. Square root of 2 over 2 minus square root of 2 over 2 That's gonna be equal to 0. And finally, I get myself an angle that does not work. And voila, I just found a counterexample.
So on the test, how do you want us to write it? Do you want us to write like theta equal to and then whatever theta we're using?
Mm-hmm.
Okay.
Yeah, naming the angle that makes it not true.
So we just have to use trial and error, if there's no way to narrow down exactly which value we should use.
True, yeah, And you should be able to narrow down pretty quickly, like this one.
Yeah, if it's
Like-
that simple, you can kind of just look at the unit circle.
Yeah, on the unit circle, literally, pi over 2 is the only one that makes this true. All the other angles are gonna make it false. This is the one angle where it works. Actually, no, two angles. Let's see. At 180 or pi, just like a watch, it's just true twice. Okay, find the exact value cosine of 75 degrees. It's interesting here, because I didn't give the. So you have a choice here. You can either do half angle formula, no, double angle formula if you like, or you could do the addition subtraction between the two, somehow get it to 75 degrees. I think I'm going to do the addition difference formula here. So two angles add up to 75 degrees. I'm going to go with 30 plus 45. Will that work? So cosine of 75 degrees would be cosine of 30 degrees plus 45 degrees. And then anybody give me the sum formula for cosine?
Is it cosine A times cosine B minus sine A times sine B?
That will work by me. Cosine of 30 degrees, cosine of 45 degrees minus sine of 30 degrees, sine of 45. All right, and let's go with it here. Cosine of 30 degrees. This is where I get to pick on people, huh? Like, Grant, what's cosine of 30 degrees?
√2.
True, okay, I'll go with it. Cosine of 45 degrees, Charlotte? Make it. Uh-huh, 45 degrees, sine or cosine is always √2/2 plus or minus, whichever quadrant you're in. Awesome. Matthias, all yours, sine 30.
It's coming back to me. It's
There's a song like that too.
1/2.
1/2 is good, and then, see Zachariah, not even gonna bug you on it, I'm gonna. So, but Zachariah, just trying to trick you, Zachariah. So this little piece right here, what's the simplified version of √3/2 times √2/2? Awesome. Trick you a little bit here. And voila, I get an answer of there. There's the exact value of cosine of 75 degrees, and we're awesome. Good, okay. Are we good there? And then, of course, give it to you in terms of radian measurements here. Let's see, 5π/8. Wow, this one may be a little more trickier here. On the homework here, you got to think about what two angles add or subtract to 5π/8. I'm thinking, let's see, let me think just for a little bit here. I got π/2, that's an angle I know, is that right? I got a π/3, that's an angle I know. I got a π/4 and π/6. Those are my little angles that I know. I don't know π/12.
I feel like you should know all the angles.
So that's 90 degrees, that's 60 degrees, 45 and 30.
Yeah.
Why don't you know at
Probably
18
not
pi
mental,
over
you know,
37.
we just don't know about it.
The power of pro is some dependent on whole. It's just half of power of six.
Uh-huh. But that's not the ones we started off with here. So I'm thinking this here. How about change everything into, if we can, denominators of 8? That just might do it. We'll see. So this guy, will that work? This one won't work. This one would work. Do we have what we need? Because this one won't work either, right?
You just can't solve it, alright, let's move on.
Wait, did you solve them yet?
No. I did some funky thing where I like tried to turn it into a degree and then tried to work it out from there, but I couldn't figure that out.
Oh, that's so cool. Okay, good, good. So I'm thinking, shoot, gotta check this out here. Hold on, then. Yeah. The other part is, how about this? Pi over 4, right? We know pi over 4, right?
Oh, I get it.
So if we do multiples of pi over 4, so let's go back to here. So pi over 4 is really 45 degrees, right? So then if you do 2 of these guys, it would be 90 degrees. 3 of these guys would be 135. 4 of these guys are at pi. Oh, there it is. Technically isn't 2 times 5 pi over 8, 5 pi over 4. Agree or disagree? Talk to me. So really, if we think about it, 5 pi over 4 divided by 2, true or false? Will that give me this right here? Uh-huh. And heard Adrian figure it out. I just want to take the credit for figuring it out, so therefore I didn't call on him.
Because you have so much to prove to us. Like, we're not still sure that you know this. We'll figure
Right,
out
yeah.
what you think.
I know it, I do know it. It's this big angle here. Okay, so then the question is, Mr. Engineer, could we really change it to degrees? Absolutely, you can change it to degrees if you like. It would be, what's the degree right in the middle of quadrant 3? 225, yeah. So if you did that, 225, what's half of 225?
Oh my gosh, I get it. I kind of figured it out.
Mm-hmm. Amaya was right there. So Amaya, when you converted this to degrees, what did you get?
I got 225 divided by 2, and I was like, wait, we don't know what 225 divided by 2 is on the circle. Then I didn't put it together. That you guys-
Gotcha. So you got what, 112.5? Is
Yeah.
that what you got? Gotcha. Okay, so let's go with it. I'm going to keep in radian measurements here, but in your mind, you're thinking 225. If you look on the unit circle, you should find 5 pi over 4. Right? Okay, so let's look at our little formulas here. What formula allows me to have that? I think that's the plus or minus, right? It's the half angle formula. 1 minus cosine of a over 2. That's the formula. So now what do we need here? Half of 225 is 112.5, right? That's going to bring us back into quadrant 2. Is that right? Since we're in quadrant 2, sine is going to be positive there. So I'm going to choose the positive value. But then down here, as we set this up, this has to be the cosine value of the angle that's there. So that's what we have, angle A here. Oop. No, sorry. Let me move it over here. Boom. So this is going to be what, a negative root 2 over 2, right? Because it's a 45-degree angle. That's cool. So then I stick cosine, which is a negative root 2 over 2 over 2, and then voila, the rest is all yours to finish up. Okay, I'll do it just a little bit here. Give you guys a head start. There, let's see, common denominators for that top value. So 2/2. Putting everything together on top. Switching over colors, and I'm going to multiply through now by a 1/2. So inside here I have that. Multiply by that. It was a tricky one, just slightly. 2 plus √2/4. Oh, not that way, has to be out now. Lots of 2's here, are we good? But it did allow us to find the exact value of sine of 5π/8, or half of 225. Adrian, good? Don't know if I'm blocking you from the screen or helping you to see the screen. So number 4, I have the slight feeling that we're not going to get through the practice test today.
That's awesome.
Okay, 4 is good. 5, jam with 5, all yours. Try this yourself. So secant t is equal to √7. Interesting. Okay, we know it's in quadrant 2. Would you be able to find the double angle formula? So what I want to do is I want to double the angle, whatever the angle is, then I want to take tangent of it. And I have no clue what the angle is in the first place. I just know the secant ratio to it is √7. All right, good. So since we're in quadrant 2, let's see, any relationship. Oh no, any relationship with tangent, double angle formula for tangent. If I go over here, start looking at my angle formulas. I have this. This is the only formula I have. Tangent. That doesn't help me much. Okay, so I guess if I'm going to use this formula, I got to convert this to tangent. So secant, it's going to be this. Maybe if I do this here, let's see, cosine. Will that be okay? Can I just do that? Secant convert into cosine as long as I take the reciprocal. So I think I'm getting closer. I guess I got to do this right here. I know I'm in quadrant 2. So I'm going to go like this. Some space to write on here. How about that? And let's see, if I do this here, definition, not on the unit circle. So that means this would be adjacent over hypotenuse. I think I like that here. So adjacent is going to be 1. Hypotenuse is √7. I guess I just need to figure out what this little guy is. What's the opposite side? Interesting. Area gives √6. So this little guy right here has a length of √6, but my coordinates right here. Ooh, that would not work, huh? Guys, can we put something else in here just real quick here? Since we're in quadrant 2, this guy would have to be negative. There's no other way.
Wait, sorry, putting that in the.
We're going to have to put it into the problem here. So we are in quadrant 2. Secant has to be negative. Let's kind of fill in the little negative pieces right here. So that would be negative. And then the negative has to go, can't go to the √7. True, because root 7 is the distance from the origin to the dot itself, right?
It doesn't
So-
go on the.
Oh, I get it.
So that little negative here has to go to the 1 here. So this would have to be the negative value. Are we good?
That still doesn't change the.
Correct, yeah. Still doesn't change the values here. So if you square this to get you root 6, as we do the coordinates, that's really what's affected right here. As you do the coordinates here, this would have to be a -1 to be in quadrant 2, and this is square root of 6. If we were to be in quadrant 3, then we would have to put a negative root 6. We're good? Just for the values to work out. Yes, okay, finally, I think we got it here. So let's plug in what we know here. 2, and now I need tangent of t. Talk to me. Oh yeah, that's right, I get to pick on people. Georgia, what is tangent of A? Or sorry, tangent of t technically, right? Because we're doing t. T angle. I don't know, something about opposite over adjacent or something for that triangle. No, we're gonna double this angle first, right? I mean, we're gonna double it, eventually we're gonna double it, right? But the formula is based upon an angle that we already know. And so notice this guy's not doubled yet. So if we want to convert, let's do this here. This will be, if we want to convert this into t values. We do know this, we just don't know what that is yet. Since we have the t angle already in terms of secant and cosine. That helps. So I'm thinking this guy has to be opposite over adjacent. We're good? Or sort of 6 over -1. Does that make sense? 1 minus, and then can I just put negative root 6? Is that okay? Negative root 6 squared. This becomes 2 root 6 on top. This becomes 1 minus 6. Okay with that, guys? -5. And I got myself my answer. So the tangent ratio of an angle that's doubled, that right there, would give me a negative.
Should the top
Yeah,
Should be positive
Top-
because the top is also negative.
Yeah, that's what I thought. And it's also negative.
Gotcha.
So then
Okay,
-1.
still thinking. Yep, thank you guys. This is a negative on top here. This should be a negative here. And then the negatives will cancel each other out on the bottom. Are we good? Is that better? It's not better, it's correct versus incorrect.
Arguably better.
Arguably better, I guess, yeah. Okay, nice. Is this helping, guys?
Unless it's
Just wanna
relevant
make sure.
exactly what
Yeah.
it is.
Okay, I think we maybe finish up this one here. All yours for this one here. Again, write it down, try it yourself.
Nice.
So about 2 sine 105 times cosine 105.
Hideous. Right.
All right. Probably this is more of working backwards here. So kind of thinking to yourself, hey, which formula does this plug into? What is this? I don't know. Start singing again. I don't know if you guys would want that though.
Wait, do you want us to tell you?
Yeah.
I
What's
think
the
it's sine double angle formula.
perfect? It's like a Yoda speech over here. But double angle formula for sine. You said sine angle double or something like that, right?
I said sine double angle.
So, there you go. Cool. It is this little formula right here. So sine of 2a is 2 sine a cosine a. Perfect. Okay, so that means if a is 105, if we double that guy, that gets us 210. So really what we're doing is we're just solving for 210. What is the sine value of 210? That you can look on the unit circle and be done. Or we could think about it. That's 210 is right over here. What, 30 degrees past 180? Negative,
Think about it, Adrian.
negative 1/2. You guys agree, concur?
Yeah.
Cool. All right, and maybe one more. Let's see.
That looks.
That's gonna be a little bit long. Let's start on this one next time.
That's like the grade for it.
This is gonna take.
Yeah.
I'll let you guys ponder that one here. That'll be fun to sort of.
You do that one and you just. keep
We're gonna have to push the
it.
test back to Wednesday. Yeah.
That's no big deal.
That's the one that you do last, because after you do it, you stop.
You look at it and you're like, maybe I'll know how to solve it in 10
So over the
minutes.
weekend, what do you want to do?
Sure.
Like,
If you
look at
guys.
your study guide?
There's not a sheet of paper.
If you guys want to finish up the study guide, send me any 5.5 questions you guys have on the homework still, and we'll do it on Monday as well. And so test on Wednesday.
What?
Bye guys, have a good weekend.
Have a blessed day.
Thank you so
Thank
much,
you.
guys. Thanks, guys. Have a good day.
You too.
Thanks.
Thank you, Mr. Hodges. Have a
Sure.
good weekend.
Thank you. You too.
My name is Sanjay. I'm really gonna.